to be discussing what makes a data science project successful. It's not all about the technology. There's a lot of things from the organizational standpoint that are very important and can dictate if a project or a data science department is going to be successful or not. We're going to be going over some common pitfalls, some solutions that we see for this, and in the end, we'll showcase a practical example of where things can go wrong and what a better alternative would be. As AI and advanced analytics are becoming more and more accessible, it's increasingly more important for organizations to also look at the way that these practices are incorporated within their existing business. We often see data science departments regarded as a separate endeavor. It's something that is worth investing into and exploring, but it's not something that you necessarily want to have in the main focus of your business. If it's successful, we'll evaluate the results and see if anything that comes out of it can be integrated into our workflow. Sound familiar? Similarly, we see a lot of departments that are set up in an obviously temporary kind of manner. The roles involved, the technology that's being used, the access they have and integration to the rest of the organization, and the communication between the department and the rest of the business is set up in a way that works for now, that will probably reevaluate and expand once the business grows organically. However, by setting the data science department in this way, it makes it pretty difficult for it to really be successful and eventually grow to that desired state. While of course there is a reason behind this and quite some benefits as well. After all, you don't need to overinvest, overallocate funds and money, or overspend on a data science department from day zero without knowing what will come of it in the end. However, this can also be limiting and even damaging to your data science department. By separating the data science practices and not holding them to the same rules that different other departments that are already established have, we're not giving them a full chance of survival. Think of a definition of success, key performance indicator, sponsorship from the executive branches, communication with the other business units, a contingency plan. Should the solution be successful, is there a commitment of what will happen next? If it's not successful, what will happen then? What makes a solution successful, and how will it be integrated into the larger scheme? Especially with something as innovative and volatile as data science, it's especially important to set up boundaries and good practices around it. Let's look at a practical example of why this can be damaging and how you can solve it. Let's say your business is in retail. You start a data science department and you think of the low-hanging fruit you can start with, but something that is big enough that can still make an impact and convince your stakeholders to continue investing in your department. We're going to settle on a case of predictive analysis. Based on the customer experience and the sales data that you have from your stores, you can make a model that will predict the demand and therefore figure out what kind of stock you should have in your warehouse. It's something that's very useful to know in advance, as you can more optimally plan and reduce waste. Sounds like a promising idea. So you take your data science department, which at this point could just be one data scientist, you give them some data, you tell them the premise of your solution, and they go ahead and work on their own. After a few months of working, your data scientist comes back with a model that has 99.8 accuracy. That's pretty successful. So you think that can immediately have a business impact, and your data science practices are amazing and you're going to keep evolving them. However, next up we have a meeting with the rest of the people in the departments that are involved in this process. So people who actually process the data from the stores, people who purchase stock or make the orders, maybe warehouse managers, people that are working in that department and they're already dealing with that problem without the machine learning model. Right off the bat, we have our first problem: data. Turns out that the files that you gave to your data scientist to make the models on are a little bit out of date. Maybe you're not selling the same products in the stores anymore. Maybe your warehouse layout is different, or the store layout. Maybe you have different providers that help you with the provisioning. Your data just looks different. And your data scientists spend weeks on hyperparameter tuning to make sure that the model performs as best as it can on those specific features. Take away the features or have a different structure in your data, your model is useless. It would take a lot of time to recalibrate it so that it works on the new type of data you have. Had your data science environment been integrated with your data platform so that the data scientist could use data directly from the stores as it was streaming in, probably anonymized of course, this problem would not have happened. This can be solved. Models can be retrained. After all, even if you're using the right data, things can still change over time, so it's something that we can account for. However, we move on to the next part of the meeting. How is the model going to be used? You bring in the people who currently make the orders for the warehouse. Based on the data they look at from the previous days, or maybe just their experience or something they just know about the process that is not necessarily put down on paper, they're the ones who make orders of what should be in the warehouse every day. Your data scientist presents the model. It would be a really helpful tool. However, when it comes to how you would integrate it into the existing process, we run into our second problem. This model uses the data from the previous 3 days of shopping to predict the next business day's need. The model also takes almost 12 hours to compute. So if you start your model at 6 p.m. as soon as the store closes and all the sales have gone through, you will probably find out at 6 a.m. the next morning what should be in your warehouse. Now, of course, that's entirely too late. The people who make the orders inform you that the deadlines are 12 p.m. a day or even 2 days before to know what the orders need to be. So your model, once again, with accuracy of 99.8%, turns out to be useless. Had you discussed with these departments in advance to tell you how the model needs to be consumed, if it's in a website that they can check, if they already have an application they use to check the sales data where a pop-up could show up or a recommendation could be another line in the table. Maybe they want a mobile app that they can use while they go through the warehouse. Any of these options could work as long as it's something that these people are willing to work with. Without that commitment, once again, there's no need to have a fancy model that cannot be used. And that's just after talking to 2 departments. Arguably, the more important things that you should integrate with: the entry point, what data comes in and where does it come from, and the exit point of your model, the newly generated prediction, how is it integrated or shown or sent to another team. If you can't figure out these things before you start a data science project, doesn't matter how accurate or how good your results are. So what's the alternative? First of all, of course, communication within the different departments and people being aware of the project that is happening, making sure that the people who will use your solution are aware and even give you suggestions or feedback of how they would like this model to be incorporated, making sure you're using the right data, making sure that the right people have access to this process and you have different check-in meetings throughout. That's just from an organizational standpoint. As we're discussing a technology solution for this, there's also different things to take into account. First and foremost, we've discussed the concept of your data science department being integrated into the existing business architecture. You need to be connected to the right data sources, you need to be connected to the right applications at the other end. And throughout, you need to be held to the same standards of security, governance, and traceability for everything that's going on in the data science department. Even the smallest project, the first project that you have in your data science department, can still have the same reliable, scalable, and extendable architecture that you would use for your department for years to come. We're talking about an enterprise-grade solution. And not enterprise as in the size of your company. It doesn't matter if you just do data science projects or if you do one data science project on the side. You still deserve to have an enterprise-grade solution in terms of the quality of it. The Azure Machine Learning platform that we're going to present as part of Microsoft's solution is not just a technical response to each of the requirements you have in the data science process. So of course, we're going to be talking about compute and Python SDKs and experiments and things that can help you to create those models that can have up to 99.8% accuracy. But we're also going to be talking about the organizational solution that it brings. It's a platform that different roles can have access to and can collaborate on. It should answer all the pitfalls that we were mentioning before and have a good solution to those. If set up properly from the beginning, with the help of one of our architects or by looking up the documentation yourself, it can ensure that data science projects are set up for success as much as possible. Of course, it also depends on the quality of the project that is being developed on the platform, but having all the right tools is already a big step forward. So having said all that, what is the solution? What does the data science environment look like and how does it work with this platform? Let's take a look at Azure Machine Learning.